Hi, Assalamualaikum. Today we will learn lesson 11, part 1, which is we are focused on the second subtopic of chapter 10. The title of this subtopic is superposition of wave. So before we discuss more about this subtopic, we check what is the learning outcome. We have three learning outcomes. The first one is to state the principle of superposition of wave for constructive and destructive interference. The second one, to use the standing wave equation. And the last one, to discuss about the progressive and standing wave. Okay, now we look at the first one. What is the principle of superposition of wave? So this principle states that when we have two or more waves meet at a point, the resultant wave has a displacement which is the algebra sum of the displacement of each wave. That means the new displacement, the resultant displacement is come from the displacement of the first wave plus with the displacement of the second wave if we have two waves that are made. Okay, let's say the first wave is represented by the green graph and the second wave is represented by the red graph. So when the green graph, which is the first wave, meet with the second wave, which is the red graph, so we look at this point. Let's say the displacement of the first wave is 3. The displacement of the second wave is also 3. So the resultant displacement is 3 plus 3, which is equals to 6. Okay, and let's look at the other point. Okay, when the green is made with the red, the resultant displacement is negative 2.7 plus negative 4, which is the resultant is negative 6.7. So we can conclude that the resultant displacement at any point is the summation of the individual displacement. Okay. Wave interference is the phenomenon that occurs when two waves meet while traveling along the same medium to form a resultant wave of greater, lower, or the same amplitude. Okay, so we have two types of interference: constructive interference and destructive interference. For constructive interference, the wave interference is said to be constructive interference if the crest of a wave meets the crest of another wave. Okay, but both of the waves must have the same frequency at the point. So let's look at this figure. First wave 1, the crest of wave 1 interfere with the crest of wave 2. As a result, this will form a new wave with greater amplitude. So this is the example of constructive interference. Let's say we have two speakers. The first speaker will produce the first wave and the second speaker will produce the second wave. And let's say both of the waves have the same frequency. Okay, so as a result, when the sound wave that come from the first speaker interfere with the sound wave that come from the second speaker, we will hear the sound that is much louder compared than the individual speaker would produce. The second type is destructive interference. The wave interference is said to be destructive wave interference if the crest of a wave meets the trough of another wave. Okay, and the condition must be same frequency. So the first wave is crest, made with the second wave, but is trough. Okay, so when the crest of the first wave meet with the trough of the second wave, as a result, the new wave will have a zero amplitude. So when the resultant wave have zero amplitude, the interference is said to be destructive interference. For example, okay, we take the same speaker as the constructive interference, but we take the second speaker move backward. Okay, so when the speaker are separated by half a wavelength, okay, let's say the difference between the sound wave that come from the first speaker and the sound wave that come from the second speaker, the difference is half a wavelength. So we cannot hear any sound if the result is destructive interference. Now we go to the next part of subtopic 10.2 related to the second learning outcome, which is standing wave. So how to produce standing wave and what is actually standing wave? Standing wave or stationary wave is produced by the superposition of two progressive waves of equal amplitude and frequency but traveling in opposite direction. This animation shows you the example of production of standing wave. Okay, now this is the illustration of the first wave that meet with the second wave. Okay, if we look at these two graphs, both have the same amplitude and wavelength, but the first wave is moved to the right, the second wave is moved to the left. So as a result, it will produce a standing wave, and this diagram show you the illustration of the graph for the standing wave. Okay, and there is a few terms that we need to understand related to standing wave. The first one is node. The symbol of node is capital N. So node point is a point that is the displacement is zero, where the destructive interference is occur. And then the second one is antinode. Antinode, or the symbol of capital A, is a point which the displacement is maximum, where the constructive interference is occur. Okay, and the pattern of standing wave is fixed, so that the amplitude of each particles along the medium are different, and we can see the node point and the antinode point appear at particular distance and determined by the equation of standing wave. Okay, this is the example of node point. This is node point, node point, node point, and node point, which is the displacement is equals to zero, or we call as a destructive interference. Okay, antinode point. Okay, antinode point is a point at a maximum displacement. Okay, and the distance between two consecutive node and antinode are lambda over 2. Okay, means from one antinode to the other's antinode, the distance is lambda over 2. Or from node to node, also lambda over 2. But the distance between consecutive node and antinode, from one antinode to the next node, is lambda over 4, which is the lambda is actually 2 times distance between two consecutive node and antinode. Okay, so this is the standing wave equation. Okay, because of the standing wave is come from the two progressive wave that is made at a point. So let's say the equation of the first progressive wave is A sine omega t plus kx. This symbol of plus show that the wave is traveling to the left. Okay, and the second wave, second progressive wave, the equation is A sine omega t minus kx. So the symbol of minus here show that the wave is traveling to the right. And both of the wave have the same amplitude, the same value of omega, and the same value of k. So by using the principle of superposition of wave, the resultant wave is the summation of individual wave. So, the displacement of standing wave is the displacement of the first progressive wave plus with the displacement of the second progressive wave. So, let's say in the mathematical solution, we let omega t as A, kx as B. So from the trigonometric, sine A plus minus B will equals to sine A cos B plus minus cos A sine B. So as a result, when we are using the trigonometric to solve this equation, so finally we got the equation of standing wave, which is it will become y equals to 2a cos kx sine omega t. A is the amplitude of the progressive wave. So, the 2a cos kx is the amplitude of standing wave at any x value. Means, at any point of x, the amplitude of standing wave is different. Okay, A is the amplitude of individual progressive wave. And 2A. Okay, 2A is the maximum amplitude of the standing wave. Okay, A cos kx is also called as amplitude formula, which is we use this formula to calculate the amplitude for any point along the standing wave. So this value, the amplitude value is depend on distance x, whereas the sine omega t determine the time for antinode and node that will occur in the standing wave. So the last part is the comparison between the progressive wave and standing wave. So the progressive wave is produced by a source of disturbance, but for standing wave, it will produce by superposition of two identical waves. Okay, which is these two identical waves is actually two progressive waves which have the same amplitude, the same frequency, the same omega and so on, which is travel in opposite direction. The second comparison, the wave profile of progressive wave is moved away from the source of disturbance. But for standing wave, the wave profile is fixed in the region where this wave is made. And then the third one, for progressive wave, the energy is transmitted along the direction of wave, but for standing wave, the energy is retained within the vibratory motion of the wave. And the last one, the knot points are not found in progressive wave because all particles in progressive wave is vibrate. But for standing wave, we will find a knot point because we have a particle that are not vibrate at all at a knot point. So that's all for lesson 11 part 1. We will continue for the second part of this lesson. Thank you.